In this example video, we're going to be graphing a line, and we're going to make a chart of data values and then plot those to create a graph. And so we're already given the x values over here on the left hand side, -2, -1, 0, 1, and 2. And all we need to do is just use the equation, which is y is equal to 2x plus 3, and substitute those x values in. So we'll write 2 times -2 plus 3 here. We'll do a little arithmetic. So 2 times -2 is -4. -4 plus 3 is -1. So when x is -2, y is -1. We can actually plot that here on the graph. So we can go left 2 and down 1. And so our point will be right here on the coordinate plane. To figure out the y value when x is -1, we can just substitute that value in. Remember, this is just the equation y is equal to 2x plus 3, except for the x here is -1 in this case. So 2 times -1 is -2. We'll add 3, and that leaves us with 1. So -1, 1 is another point that's on the graph. We can do this with the other points, so we'll do that down here. And we'll try 0 next, so it's 2 times 0, and then plus 3. So that's 0 plus 3, which is just 3. And then we've got 1, so we could go 2 times 1 plus 3. So 2 plus 3 is 5. And we can do the same thing again here with 2. We're just getting some representative points to help us see the shape of this graph and to be able to draw a nice, accurate line in this case. So we can go back here to the coordinate plane, and we've plotted the first two here. We can plot the next 3. So 0, 3 is right here, and that's a special one. 0, 3 is the point where the graph crosses or intersects the y-axis. We call it the y-intercept. 1, 5 is another point on our graph, and then 2, 7 also. So if we continue this pattern, you can tell here that to get from one point to another, we just have to go, well, it would be up 2 and right 1, up 2, right 1, up 2, right 1, and so on. Or we could go down to left 1, and that will be a point right here. Down to left 1, down to left 1. That just helps us to graph a little bit more accurately. We're going to try to do the best job we can here. This is not the world's most perfect line. Please try to do this with a straight edge when you're here at home, but we'll just have to go with it here for the graph. So for part A here, we've successfully graphed y is equal to 2x plus 3, and we've done that by using a chart of values. So let's move on to the second and wait for this to pop up on the screen. Here we are. So we've got a wonderful problem here. Try to blow this up just a little bit for you. And this is my first time using this program, so it's a little finicky. Hopefully this will be okay. Alright. So what we have now is we have another equation, y is equal to -3x plus 1, but we don't have any x values. We get to choose those. I like to choose values of x that are going to be on the graph, and so I'm thinking here -7 to 7, and I'm probably going to stay with that -2, -1, 0, 1, and 2. Let's see what happens when x is -2, and I'm looking right here at the equation at the very top, and all I need to do is just substitute this x value right in there, and we will figure out what that corresponding value of y is. So let's see here, -2, then plus 1, so -3 times -2 is 6, and we'll have 6 plus 1, which is 7. So -2 and then up 7 would be right here. If you ever substitute an x value in that has a corresponding y value that's not on the coordinate plane, there's a couple things you could do. You could change the scale if you really wanted to, or just pick another value of x. You can pick a better value of x. Let's try the next one. Let's try -1. So we'll go right back to our equation. -3 times -1 plus 1. So that's 3 plus 1, which would be 4. So we can go left 1 and up 4 and plot that point. The next one's going to be the y-intercept. That'll happen anytime x is 0. And if we think about it, if we look at the equation right here, this term, -3x, well, when x is 0, anything times 0 is 0, and so this term right here is 0. It's kind of gone when x is that value, and we're just left with 1. So we can reason through that a little bit and say, well, the y value must be 1. So we would say that the y-intercept here is 1. Let's try just a value of 1 here. So we'll move on to the next one. -3 times 1 plus 1 is -2 plus 1, which is negative, oops, almost made a mistake there. How about this? How about let's make -3 times 1 what it's supposed to be. It's -3. We'll add 1 and we'll get -2. Now, those of you are watching this at home or wherever you're watching this video, you might say to yourself, well, how in the heck did he catch that mistake? One thing that I know is if I'm graphing a line and I make the change in x the same thing, so in other words, to go from -2 to -1 is 1, then from -1 to 0 is still 1, 0 to 1 is 1, and so on, then the change in y must be the same thing. So from 7 to 4 we would subtract 3, from 4 to 1 subtract 3, and then from 1 to, well, before I was going to write -1 and that just wouldn't work. 1 minus 3 is definitely -2. So try to use that reasoning, think outside the box a little bit and see if your values make sense. That's a really important thing to do. Now that we actually see that that does make sense, and you might have caught that when you graphed it here too. If you graphed 1, -1, it would cause the line to have like a slight kind of curve right there, and we wouldn't want that to happen, at least in this case. Let's try the next one, -3 times 2, and then plus 1 again. So that's -6 plus 1, which is -5. So this point is 2, -5. And we can see that these all line up in a nice straight line. So we can try to draw our line as best as we can here. Straight through those guys. Put arrowheads at the end. We're just graphing some representative points, but any point on the line, even if it's in the middle of the grid lines, that will balance this equation and make it true. Well, I hope you've enjoyed this video, and I hope you found it informative. And good luck graphing lines using a table.